Section 2.6, let's look at data types integer or the whole numbers. Integer variable can hold whole numbers such as 12, 7, minus 99. When you are counting the bodies of the student in the classroom, you say, I have 20 students in a class. This would be using a type of integer value to work with. Let's look at the integer data type and their size. You can express your integer in the form of the short integer, and that would give you 2 bytes ranging from 32,768 negative to plus 32,767. Unsigned short integer, since it's unsigned, still it takes 2 bytes, but it would have from 0 to 65,535. That's fairly a large number to work with. The integer itself will take 4 bytes, and again you have a large number of 2 billion, from minus 2 billion to plus 2 billion. You have unsigned integer, which is from 0 to 4 billion, and it takes 4 bytes. Then you got the long integer, would basically work out to be the same as your regular integer, from minus 2 billion to plus 2 billion. And you got unsigned long integer that will give you a range from 0 to 4 billion. And that's fairly large amount of numbers that you can work with. If you have to work with numbers bigger than those, then you have to work with the machines that are a true 64 or a high bit number, and then work out with bigger range of the numbers for your integers and longs. Defining variables. Variables of the same type can be defined on one statement. For example, if you are using integer length, integer width, and you have unsigned integer area, and you have on the same line, putting it together, integer length, comma, width, semicolon. That is to combine those two statements at the top with one statement to show that length and width are of type integer. And then you have your next line, unsigned integer for the area. Variables of different type must be in different definition. That's why we separated the integer from unsigned integer into separate lines. Here is another program. I would like you to code this one. And this program will have 3 variables. Okay, checking, miles, and days. Again, it is using the checking as an integer variable, miles as unsigned integer, and days as a long integer. Notice in the statement 11, we are assigning a negative 20 to checking. We are assigning in the statement 12 another integer to the mile, and we are assigning another long integer to days. Then we are outputting on different statements these variables. Let's look at the output of the result. Once you run the program, you'll see the output as it's shown also in your book. The integer literals, an integer literal is an integer value which you can type into your program directly in an expression or a statement, and it has the value of the integer that you are assigning it to be. For example, if you want to assign a value 15 into item ordered, you basically type in 15 in that statement. 15 is integer literal. You may say, what difference does it make? Well, if I'm using different data type and I put the 15 inside codes, then it doesn't have the numerical value of the integer. I cannot do calculation and mix and match after typing with it. Getting back to our program that we're working with, let's look at the integer literals that we have. Again, on line 11, 12, and 13, we have those numbers minus 20 and 4276 and 189000 as integer literals. Okay. Integer literals are stored in the memory as integers by default. To store an integer constant in a long memory location, you put a L at the end of the number. Again, here is an example of 1, 2, 3, 4 L. To make it, it's a long form. Constants that begin with 0 are base 8, and constant that begin with OX are base 16. And this would be the end of section 2.6.